and welcome to the 5th tutorial in this series on fractions. And don't worry, it will end. I know it seems like a lot of tutorials, but fractions, as I said at the beginning of this series, is so important and fundamental in the study of maths, and it's such a barrier for so many people in pursuing their math studies because they're unsure of fractions. It really is worthwhile doing a proper job on this topic, and so if you go through each of these videos in the series, I really hope that you'll have a much better understanding of fractions and be much more confident going forward in manipulating fractions in the many different situations in which you'll find them as you study maths. So in the last tutorial, we quite carefully and rigorously went through adding fractions, and in this tutorial I'm just going to show you the very similar method of subtracting fractions, and I'll also just take into account adding and subtracting mixed numbers as well. So fractions continued, and here, as I say, we'll be talking about subtracting fractions. Now, I'm not going to do anything conceptual with this. I'm just going to show you the methods, because I think conceptually you'll be very clear on this given the discussion in the last tutorial. So let's maybe just take a simple example of 1/2 take away 1/3. And as we did in the last tutorial, what we'll do here is multiply 1/2 by 1, but we're not going to write 1, we're going to choose to write 1 as 3 divided by 3, and then take away 1/3, and I'm going to multiply 1/3 by 1, but I'm going to choose to write 1 as 2 divided by 2. And I'm doing this in order to get the same denominator in each case. So multiplying these two fractions together, I will get on the top 1 times 3 is 3, and on the bottom I'll get 2 times 3 is 6. Take away, multiplying these two fractions, on the top 1 times 2 is 2, and on the bottom 3 times 2 is 6. And you see now I have a very simple piece of arithmetic, because I have 3 lots of something take away 2 lots of something, where that something is 1/6. So 3/6 take away 2/6 will leave us with 1/6, and that is the answer. Let's just do another example. I will just make this up in my head. So 3/7 minus 2/9. So a slightly more scary looking example. I don't know what the answer is, so we'll have to find out. I'll do this by two methods. I will do it the careful way that I've described here, and then I'll use the cross multiplication method that we discussed also in the last tutorial, which is a more streamlined way to do these addition and subtraction problems. So let's do the careful method first, which is more designed for clarity, so you understand why these methods actually work. So 3/7 then, I'm going to multiply by 1. I'm going to choose to write 1 as 9 divided by 9. And then take away 2/9, and I'm going to multiply 2/9 by 1, and I will choose to write 1 as 7/7. I have some fraction multiplications to do. So on the top I have 3 times 9 is 27, and on the bottom I have 7 times 9 is 63. Notice that when you're doing these more complicated fraction additions and subtractions, it's extraordinarily helpful to have your times tables to hand, so you're not stumbling over these simple steps. Most viewers will be fairly confident with their times tables, some will not. I will make a tutorial sometime in the near future to go over the times tables, to try and give everyone confidence so they can learn their times tables easily and use them as a simple tool. So we have 27/63 for the first one, and then in the second one I have 2 times 7 is 14 on the top, and 9 times 7 is 63. And again, you'll be getting bored of this by now, but you'll see we have the same denominator, so we have 27 lots of something minus 14 lots of something, the something in this case being 1 over 63, a 63rd as it were, and I just have to subtract 14 from 27, which will give me 13 lots of a 63rd. So the answer is 13 63rds. So even a scarier example like that really is relatively straightforward to evaluate. Let's just redo that one using the cross multiplication method. So 3/7 minus 2/9. By cross multiplication, I'm going to take this number upstairs and multiply it. So I have 3 times 9. I'm going to take this number upstairs. Notice I'm going to put the right sign here, so it's minus because we're doing a taking away sum. Bringing the 7 upstairs here and multiplying it by the 2, all over the product of the denominators, so 7 times 9. And I have 27, take away 14, all over 63, which is 13 over 63. So you can see really this technique of cross multiplication is just a very helpful way to cut to the chase with this longer method. It's really the same conceptual underpinning, but just a bit faster in terms of manipulation. So let me just spend the next few minutes and end this tutorial by talking about adding and subtracting with mixed numbers. Let me just make up an example. Let's say we have to add 1 1/4 to 2 1/5, for example. Okay. Now, given that these whole numbers in these mixed numbers are relatively small, one way to go about this is just to convert both fractions to improper fractions. So 1 1/4 we can write as 5/4, and then we're adding it to 2 1/5. Now, if I want to think of 2 in fifths, it would be 10/5 plus a fifth is 11/5. Alternatively, I could have used that method I talked about in the second tutorial. Or was it the first tutorial? I think it was the first tutorial where we multiply this by this, add this, and take it over 5. In either case, though, you'll see that this is 11/5. And then I just have a fraction addition problem. Let me do it with cross multiplication to give practice. So take this number upstairs, and I have 5 times 5, plus, make sure I get the right operation, plus or minus, it's plus here, and then take this number upstairs, that's 4 times 11, all over the product of the two denominators, 4 times 5. And I have 25 plus 44 all over 20. And therefore this is equal to 69 over 20. And you could leave that as the answer. You might wish to bring it back into a mixed number representation. In that case, I have to ask how many 20s are there in 69? Well, there are 3, because 3 lots of 20 give me 60, leaving 9 over. So I would have 3 lots of 20 gives me the whole number 3, plus a remainder of 9/20, which I can write as 3 and 9/20 in that mixed number representation. I would probably prefer to leave it in this form personally. Let's just do one more example with a taking away sum. Let's say we have, I'm just making this up as I go, so 2 1/7 take away, I'll choose a larger number, let's choose 4.5. And again, because these whole numbers are not too big, I think it's probably fairly quick to turn them into improper fractions. If the numbers involved are quite large, it's more sensible to separate this into a whole number sum and a fraction sum, and maybe the final example I'll choose to do it that way. So let's see, turning to mixed fractions then, we have 2 1/7 is 15/7. Take away 4.5, that's 9/2. I'll do this by cross multiplication. I'll take this 2 upstairs. It will be 15 times 2. Get the operation right. Now it's a takeaway sum, so I put minus here because I'm taking away. Take this number upstairs, 7 times 9, all over 7 times 2, which is equal to 30. Take away 63, all over 14, which is negative 33 over 14, and that would be the answer. As a final example, if we had, say, something large like 100 and a third, take away 57 and a quarter, it's more sensible here to just remember that a mixed number literally means 100 plus 1/3. And let me put that all in brackets. Take away 57 plus, because this mixed number means 57 plus a quarter. And to separate this into two different sums, I have 100 take away 57, and then I have a third take away a quarter. And you see, really, I have two separate takeaway sums going on here. The first one involves whole numbers, and it would give me 43. And then I'm adding to it the result of this fraction, subtraction, which I will just do in my head. It will be 1/12, and so the answer would be 43 and a 12th. So if you have large whole numbers in a mixed number, I would not recommend turning to improper fractions, because you'll just get such large numbers that it will become quite unpleasant. So in that case, it's more sensible just to separate into a sum involving whole numbers, and then to deal with the fraction separately, but taking great care with the signs, though. You see that 1/4 there is definitely subtracted from the third. Right, so I think we're done with adding and subtracting fractions, and in the final tutorial in this series, I'm going to deal with converting everything we've learned into an algebraic form so that you can manipulate algebraic fractions, and I'm hoping that you will see it is utterly straightforward as long as one is confident with the arithmetic aspects of fractions that we've learned so far. So thank you, I hope it's been helpful, and I will see you next time.